All right. In this lesson, we're going to continue looking at our next organic family, which is esters. Now, esters are characterized by this functional group that we see at the top of the screen, and it does not. It's another functional group that does not have its name. So, an ester is a organic molecule that has been formed from a carboxylic acid and an alcohol, and that the carboxylic acid and the alcohol have undergone a reaction called an esterification reaction, which is basically condensation, so it releases water. And when that happens, a carboxylic acid and an alcohol join together. So the carboxylic acid is characterized by a carbon with the double bonded oxygen that comes from a carboxylic acid attached to an oxygen that comes from an alcohol. So when we name our esters, this is really annoying. I'd like it to go away. I don't know. When we name our esters, we have to recognize that there's three parts to an ester. So the name of an ester comes from we use the name of the alkyl group to represent the alcohol. We name the parent chain of the carboxylic acid, and then it gets the ending O8. So let's look at an example. We're going to look at a couple examples. So here are three examples. I think there we go. Okay. So the naming of the ester, we do the alkyl group that represents the alcohol. So in our first example, the alcohol is always the carbon chain attached to the single bonded oxygen. The alcohol is the carbon chain that is attached to the oxygen, which is the connector. So there's only one carbon here, so we call it methyl. And then the next part of the name is the parent chain for the carboxylic acid. This is nice and simple because it's just two single bonded carbons. So it's ethane. And then because we have this connecting everything together, it's O8. So we look at our next example. Our alcohol parent chain right here is two carbons, 1, 2, and the alkyl name for that is ethyl. So ethyl. And then the carbon chain of the carboxylic acid is 1, 2, 3, 4 carbons. I want you to note that the carbon involved here is still counted. So there's 4 carbons. And they're all single bonded. So that's butane. And then right here, O8. So a ester looks very similar to an ether, but they're named very differently. And the ester has that double bonded oxygen. So that's how you can tell the difference. The ester is just carbon chain, oxygen, carbon chain, whereas the ether is carbon chain, oxygen, carbon chain, but the ester has the double bonded oxygen. Okay. And then our third example we're going to look at here. We have 4 carbons coming off of the oxygen from the alcohol. So that is butyl. And then 3 carbons involved in the carboxylic acid, so propane, and then O8. It doesn't matter which chain is shorter here, like it does in the ethers. The naming tells us what the alcohol was and what the carboxylic acid is. Okay, so that is another difference. We don't put the shorter chain first in the esters. The name of the alcohol comes first, and then the name of the carboxylic acid comes first, and then the ending O8. Okay, so just make sure you have that copied down. We'll look at some properties of esters. So when we look at what's going on with an ester, the functional group is polar, but it's in between two non-polar hydrocarbon chains. So this means that it's slightly polar. It is going to do dipole-dipole intermolecular forces a little bit, but there's no hydrogens available for hydrogen bonding. I know there's a lot of hydrogens in the molecule, but none of those hydrogens have a partial charge. They're all in non-polar bonds. So there's no hydrogen bonding going to happen in an ester. Because of that, the physical properties reflect that. It's going to be a lower melting boiling point than carboxylic acids and alcohols because those two will hydrogen bond. It's going to have a higher melting and boiling point than alkanes because it does make those dipole-dipole intermolecular forces. The polar carbonyl group, though, is strong enough to allow smaller esters to be soluble in water. So some of them will dissolve because the polar group is strong enough to let that happen. But the bigger the ester gets, the longer the hydrophobic hydrocarbon chain is, so the nonpolar part becomes, the less soluble it's going to be. And large esters are soluble in nonpolar solvents. Okay, so an ester would probably be soluble in maybe an ether. We talked about how it will dissolve polar and nonpolar. And esters are very aromatic, which means they have really strong odors. Now, some chemical properties of our esters. So I'd pause and make sure you have these properties down. All right, so back to chemical properties. They can undergo hydrolysis, which means if we add a water molecule, it will reform a carboxylic acid and an alcohol, so it will separate out into what it is made from. And esters are used to make soap. It's called saponification. So that is a big purpose and actual use of esters, is they're used to make soap. But there's a long list of other applications. Our applications where we might use esters, they occur naturally in plants and are really responsible for the odors of plants and flowers. And synthetic esters are used for flavorings in processed foods. They're used in scents, in cosmetics and perfumes. They're an organic solvent, which means you can dissolve things in them. Natural esters are the pheromones, so things that insects and animals use. The esters are the backbone of DNA, so that's something that you might have looked at in 4U. Nitroglycerin, which is an explosive, is a common ester. We already talked about using it used in soaps, in detergents, and a big one is that it can be used in plastics. So making sure you have those uses copied, and then we'll look at the reaction where carboxylic acids and alcohols create the ester. Okay, so esterification reaction. Now this looks really, really busy. So I'm going to suggest you hit pause, copy this down, and then listen to me explain it. So esterification reaction is basically condensation, which means that it releases water. It's a condensation reaction between the carboxylic acid and an alcohol. By doing that, it connects the carboxylic acid and an alcohol together and releases the water. So let's take a look right now at our reaction. So in our reaction, we have butanoic acid, so 4 carbons and a carboxylic acid with that carboxylic acid functional group. And we have an ethanol, so 2 carbons with a hydroxyl group right here. Now, it doesn't matter if it's a primary or secondary alcohol. Either one of them will undergo esterification. What happens is the OH in the carboxylic acid and the H in the hydroxyl group, they hook up and make water. The bond here, the electrons connecting this hydroxyl to this carbon, end up coming over and joining to this oxygen right here. So these electrons come here and join the carboxylic acid piece to the alcohol and releases water. It's important to remember the oxygen involved comes from the alcohol. And then our name for this is ethyl for the two carbons down here, butane for the 4 carbons here, O8 for the fact that they're connected right here. Now, this reaction requires a sulfuric acid catalyst. You have to have some sulfuric acid to make this happen. It's a catalyst, so it's not used up or consumed in the reaction. Unlike the oxidization agents we needed in our previous reactions, it's not actually involved, but it speeds it up. So we look at another example. Here's another example. Jaws esterification reaction for an ester forms between 1-propanol and benzoic acid. So benzoic acid is a benzene ring with a carbon and then that carboxylic acid functional group. 1-propanol, 3 carbons with the hydroxyl on carbon 1. So what happens is, again, this oxygen and this hydrogen, they meet up, they leave, and everything gets connected here, and we make this ester propyl benzoate. Now, another important reaction, so once you have this copied, another important reaction is the fact that an ester will undergo hydrolysis in a basic solution, which means it will react with a base to produce a salt of the carboxylic acid and water. So if we have our ester here, we see here, what happens is the oxygen involved from the base ends up connecting the metal ion to an ion of the carboxylic acid. And it makes a salt. Okay, that's all I'm really going to care about is the fact that you recognize an ester will react with a base to make an ionic compound, okay, which we sometimes call a salt. And the salt is a carboxylic acid that is an ion and a metal. So that is our esters note here. Again, I'm going to post some practice for you, and I'll probably include an esterification reaction in your assignment. So that's it for now.